Hello everyone, my name is Ali. Today I'll be demonstrating the hydrocyclone practical for METL2201. In this experiment you'll see how a hydrocyclone separates particle based on different size. This specific hydrocyclone configured to separate particle down to 5 micron. Okay, let's go through the steps together. The first step is pre-start checks. Before starting, please complete your risk assessment on the form. You can use the risk assessment available on Blackboard. That's a template that you need to read it beforehand, and then you can complete your risk assessment during the practical. Next, you want to ensure the main water supply is connected and turned on. Next, check the power outlet type and the plug type as well, and find a suitable one, and then you can connect the plug in the power outlet and you can turn the electricity on. Then confirm that the inlet valve is fully closed and the pressure gauge reads 0 before start of the experiment. Before starting the experiment, you have to make sure that the bypass circulation valve, which is in black, is fully open. What this does is allows water to circulate without entering the hydrocyclone, and also this protects the pump, so it let the water going through the generator and the pump, and also cooling the system. It is important to remember that before closing the bypass valve, you have to open the hydrocyclone valve first to let the water circulate still through the pump and the system. So basically, first open the hydrocyclone valve. When you see the water circulate through the hydrocyclone, then you can close the bypass valve. So you protect the pump by doing that. Once the hydrocyclone is active, it produces 2 output streams: underflow, coarse particle from the bottom, and overflow, which is the fine particle from the top. Well, the next step is feed preparation. We have a sample containing aluminium oxide and zirconium oxide that we used previously for hydrocyclone. You have to weigh this sample about 500 grams and add the dry mixture into the hydrocyclone tank. Well, the next step is to start the water circulation. To doing that, slowly open the water inlet valve. The pressure should rise to around 300, which means water is flowing into the system. Watch as the bottom tank fills with the water, but you don't want to fill it all the way. So once the tank is filled to a line that you can see inside the tank, you can start the circulation pump. Water will begin flowing through the system via the bypass loop. At this point, the hydrocyclone is still inactive. No flow is entering in the hydrocyclone. With the system circulating the water, begin feeding the solid into the tank and let it to circulate for about 5 seconds. Next is to start the hydrocyclone. Here we need to act quickly because the tank constantly filling up with the water. So how to do that? First, slowly open the hydrocyclone isolation valve and then slowly close the bypass valve. Okay. At first, you can see that both the streams, underflow and overflow, go back into the tank still and circulating through the system. After a few seconds, as I said, the slurry will be well mixed. Now, at this stage, you can redirect the output by moving the head. By adjusting the head, you will collect the underflow in the blue top and also collect the overflow in the yellow top. So slowly you collect the sample, both tops getting filled with the overflow and underflow samples. As the samples are collected, the tank level will drop. When the slurry level reaches the bottom of the tank, you need to stop the pump immediately and also close the inlet valve to isolate the system. The next step is filtration. We use the filter press to remove the water from the slurry, and what we end up with is the filter cake. To do that, the first step is to label each filter paper with your group name and sample ID and also the weight of the paper. Placing the filter paper on the bottom of the filter press machine and put the filter press back on the paper. Make sure it's sealed all around the paper so you don't have any spillage while you're pouring a sample in. Then you can slowly pour the slurry into the filter chamber. Depends on the quantity of the slurry that you have. You might need to do filtration a couple of times. After you pour your sample in, you can close the lid slowly, and when the lid is tight, open the red valve to apply the air pressure into the filter chamber. The pressure will go up to about 40 psi. And if you look at the bottom of the filter press, you can see the bucket is in there and the water will drain into the bucket. This takes about 1 minute or 2 minutes. After the water completely drained, you may close the red valve, and you can see that slowly the air pressure release and the gauge going down from 40 psi to about 10 or 5. That's the time that you can open the lid and you can collect the filter cake, place that filter cake on the drying tray, and then you can transfer them into the oven and keep it in the oven for 24 hours to dry. At the end, you need to make sure that area is left clean for the next group. You can flush all the valves and hoses with the clean water, wipe down the bench, put the tops away and make sure they're all clean. Check the power outlets, turn it off, and also check your water supply and turn that off as well. After the practical, each group will receive their hydrocyclone output data. You will use this data to plot a mass split with particle size chart, calculate the partition coefficient, and also draw the hydrocyclone performance curve. This will help you evaluate how efficiently your hydrocyclone separated particles. That concludes the hydrocyclone practical video today. Thanks for your attention and best of luck with your practical and analysis.